Hello, everyone. I'm Lisa Wang, a PhD candidate from Colorado State University and working with Professor Joe Van Link. Glad to be involved in this session of performance risk resiliency-based engineering in Agriculture. I want to give a presentation today with the title of Probabilistic Decision Support Methodology to Improve Community Resilience to Tornadoes, Integration of Physical Infrastructure and Social Economic Systems. The motivation of our study is definitely to improve the community resilience, and the figure at the left-hand side shows the conceptual description of resilience. So we can retrofit our buildings to improve their performance to resist the hazard, and also measure the structural response immediately after hazard, and examine the recovery after the hazard. The first section of my presentation today is a multidisciplinary community resilience matrix. In this section, we examine the effect of a tornado damaging physical infrastructure and the effects on the population and the local economy. And then we propose 3 residential building retrofit strategies as alternatives to improve community resilience and explore the effects of mitigation strategies on multidisciplinary resilience matrix. The figure at the left-hand side shows our framework of this session. First, we have independent community modeling, including physical environment, economic system, and social system. And after applying the hazard model and using fragility functions, and we have the infrastructure functionality here, the building functionality due to damage and or electric power network. And then we link the functionality to an economic model, CG model, computable general equilibrium model, and also a social science model, population dislocation model. And finally, we can determine the resilience matrix in terms of physical service matrix, economic stability matrix, and population stability matrix. More specifically, we can determine the percentage of buildings functional due to damage and or electric power loss, or such as domestic supply by sectors, employment, household income, or the percentage of population dislocation, which can be tracked by different housing characteristics. The figure at the left-hand side shows our Joplin building environment with our 19 building archetypes, including residential, commercial, social institutions such as schools and hospitals. The table at the right-hand side shows our housing unit inventory. As you can see, our inventory can be classified by the tenure status, such as owner-occupied or renter-occupied. And also it can be grouped by 1-person household to 7-person household, also group quarters such as dormitory and beacon units. All of our building damage and electric power network, such as substations and wooden poles, are driven by fragility functions. As you can see, we have a full set of fragility function for all our 19 building archetypes and electric power network. Then let's move forward to the functionality. So the figure at the left-hand side shows our interdependency between buildings and substations. As you can see, each blue dot is each substation, and each substation can provide electric power to buildings in its service area. And the table at the right-hand side shows a simplified Joplin social accounting matrix example. So the social accounting matrix is the most important matrix, most important input for the CGE model. When the natural hazard occurs, it will give a shock to the CG model, and the original equilibrium status of the CG model will move to a new equilibrium status and then determine the employment, domestic supply, and household income through the entire community. And our population dislocation algorithm actually is regression equation model, which can be linked to the building fragilities. And we also have some value loss or consider minority populations and housing information such as the number of people, vacancy, and tenures. And finally, we can determine the dislocation probability for each household. And here we propose 3 retrofit strategies based on different structural elements, such as roof covering. We use asphalt shingles or clay tiles, and the roof shading newland python, or roof to wall connection type. We use the toenails or hurricane clips. As you can see, the figure at the right-hand side, if we use a retrofit strategy 3, the percentage of buildings within tornado path functional can be increased from around 3% to more than 41%. Then let's move forward to the socioeconomic resilience matrix. So first, we can see the results from the perspective of the entire community. We can see when using the retrofit registry, since the building performance has been improved, so therefore our economic loss can be reduced accordingly. And also, more and more residents would prefer staying at home and not choose to dislocate. So we can provide the household dislocation tracked by different housing characteristics such as tenure status, whether the households are owner occupied, renter occupied, or by race ethnicity, such as the household are white or black or any other or Hispanic, or dislocation by household income, grouped by different household income range. And we can also measure the socioeconomic resilience matrix from the perspective of an interdependent physical social relationship. For example, here we can allocate household to each building, and we can check the housing characteristics of dislocated household, but remaining in functional buildings, and also residential household, but remaining in non-functional buildings. And we can also check the matrix from the perspective of social service. So for example, we can check our dislocated household by their dependent K-12 schools. So if households choose dislocate, their kids, their children cannot continually receive the education as usual. My second session for the presentation is the aggregation of multidisciplinary community resilience skills. So here we developed multidisciplinary community resilience skills targeted for routing levels, design levels, and stream levels of tornado events. And then we de-aggregate performance targets for individual residential buildings and determine the percentage of buildings that should be retrofitted to achieve community level resilience goals in terms of physical, social, and economic metrics. And also the figure at left-hand side shows our framework. First, we need to select the goals in terms of physical performance, socioeconomic matrix. For example, we want to keep less than 3% housing units dislocated after an EF3 tornado. And then we can develop the preliminary design for individual residential buildings, and then perform the community resilience assessment and determine the socioeconomic matrix as I mentioned earlier, and see whether our community performance can meet the resilience objective we set at the beginning. If not, we revise the design and redo the resilience assessment until we found that the resilience performance can meet the resilience objectives. For example, the table at the top shows our community resilience goals in terms of a physical service matrix, population stability matrix, and economic stability matrix. And here we can see we can keep the percentage of building remaining functional due to damage and electric power, and the percentage of household or population dislocated, and the percentage of change in employment, domestic supply, and household income. And here we have our retrofit design for residential buildings as I mentioned earlier. And here we develop 100 generic tornadoes for different level EF2, EF3, EF4 in different directions, different lengths, and different start point, end point. And for each tornado scenario, we retrofit our residential buildings from 0% to 100% randomly in interval of 10%, and then perform the resilience assessment until we found the resilience performance can achieve the resilience goals we set at the beginning, and we can determine the percentage of the residential building that should be retrofitted. For example, in order to achieve Goal A, the household dislocation matrix control the retrofit level and at least 34.2 of residential building that needed to be retrofitted. The summary of my presentation, we propose 2 sessions in total. And the first, we can determine the multidisciplinary resilience matrix, and we'll link our traditional building damage model, building functionality model to the CD model and the population dislocation model, etc. And we can determine or measure the socioeconomic resilience matrix from the perspective of the entire community, or from the perspective of an interdependent physical social relationship, or from the perspective of social service. And the second session is we can de-aggregate the multidisciplinary community resilience goals, and through we can retrofit our residential buildings in different levels, and through the tornado simulation, finally we can determine the percentage of residential buildings that should be retrofitted. So that's my presentation, and thank you for listening, and I'm happy to have any further discussions. Feel free to send me email and we can communicate. Thank you very much.